In today's video, we will be discussing Hamming code. Hamming code is a type of block code. First of all, the length of Hamming code is always n, where n is equals to m plus k, where this m is equals to length of data and k is equals to length of parity bits. So length of Hamming code can be calculated by m plus k. Now, how you can calculate? Suppose your data is 1010. So what is the length of the data? It is 4-bit. So in place of m, we will place 4. So it will become 4 plus k plus 1 should be less than or equal to 2 raised to the power k. Now we will put different values of k to satisfy this equation. Let us say we will put k is equals to 1. So what will equation will become? 4 plus 1 plus 1 will be 6, less than or equal to 2. So this condition not satisfied. Now put k is equals to 2. This will become 4 plus 2 plus 1, that is 7, and 2 raised to the power 2 will become 4. So again this equation not satisfied. K is equals to 3. So 4 plus 3 plus 1 is 8. And 2 raised to the power 3 is also 8. So we have two conditions, less than and equal to. So equal to condition is satisfying. So we can calculate, or we can now understand that the length of parity bits are 3. So what will be the length of Hamming code? It will be 4 plus 3, which is 7. So one thing is clear. If you have 4-bit data, you will have to calculate or construct the Hamming code of 7-bit length. So for every 4-bit data, you will be getting a 7-bit Hamming code. Now how you will construct a 7-bit Hamming code? So for that, you have to consider 7 positions, and the 7 position numbering I am writing in the reverse order. Now, what is the concept and how we are calculating? We will just understand. This way you will be entering the data. This way means from left to right. So data will always enter from left to right. And parity bits, these are always entered from right to left. This is what the condition. Now you have how many parities? 3 parities. So parities we will denote by P0, P1 and P2. These 3 parity we will be denoting. Now what is the position of parity bits? Where these parity bits needs to be placed. So why I have kept the suffix as 0, 1, 2 instead of 1, 2, 3? Because this will be in 2 to the power. That means 2 raised to the power 0 is 1, 2 raised to the power 1 is 2, and 2 raised to the power 2 is 4. That means first position will be for P0, second position for P1, and fourth position for P2. So the parity bit positions are now clear by this process. Now we need to enter our data. So our data is 1010 and data entry is from left to right. So this will be 1, 0, 1 and 0. So the remaining empty spaces will be filled by the data, that is 1010. Now we need to calculate P0, P1 and P2. That means either P0 will be 0 or P0 will be 1. Same way P1 and P2 are also either 0 or 1. So now we will calculate whether P0 is 0 or 1. So for that we need to again calculate P0, P1 and P2 by one method, which is, now you have 7 digits. So now what you will do, you will convert these 7 decimal numbers into its corresponding binary number. So the binary conversion of 1 is 001, 2 is 010, 3 is 011, 4 is 100, 5 is 101, 6 110 and 7 is 111. Now you have three columns. This first column is denoted by P0, second column is denoted by P1, and third column from the right to left is P2. So now we will check the column P0, and in this column P0, the places where bits are 1, we will consider those decimal numbers. So for your convenience, I have written the decimal equivalent of these binary bits. Now I will complete this bracket of P0. This will be 1, 3, 5 and 7, because at these positions bits are 1. Similarly for P1, 2, 3, 6 and 7. So in this bracket 2, 3, 6 and 7 will be there. Finally P2, 4, 5, 6 and 7. So we will write 4, 5, 6 and 7. Now 1, 3, 5 and 7. At position 1 it is P0, 3 it is 0, 5 it is 1 and 7 it is 1. Similarly 2 it is P1, 3 it is 0, 6 and 7 it is 0 and 1. Then P2, 1, 0, 1. So all the numbers and corresponding bits I have written here. Now after all this process, we need to calculate the Hamming code, and there are basically two types of Hamming code. One is known as even parity Hamming code, another is known as odd parity Hamming code. So if in the exam they will ask calculate the Hamming code, so by default you have to calculate the even parity Hamming code. If they specify, then only you will calculate the odd parity Hamming code. Right now what we are doing is we are calculating even parity Hamming code. So for even parity Hamming code, number of ones in every bracket should be always even. So right now how many ones you can see? There are 2 ones, that is even. So to make it even, P0 should be 0, because if it is 0 then 2 0 and 2 1, number of ones are even. Now suppose we have to calculate the odd parity Hamming code. In that case this 0 will become 1, because now we need to keep the number of ones as odd numbers. Okay, got the idea? Similarly in this case P1, 0, 0 and 1, how many number of ones are there? Only 1, that is odd. So to make it even, P1 bit will be 1. Similarly P2 will be 0, because there are already 2 ones present. So that is number of ones are already even. So P2 bit will be 0. So now instead of P0, P1 and P2, if I write these numbers, it will become 1, 0, 1. P2 is 0, 0. P1 is 1 and P0 is 0. So these 7 bits are the corresponding Hamming code of the data 1010. So that means if you have the data 1010, your Hamming code will be 1010010. These 7 bits are known as the Hamming code of these 4-bit data. So I hope you understand the concept of constructing the Hamming code for a given data bit sequence. So this way we can calculate the Hamming code. I hope you understand. If you have any further doubt, you can write it in the comment section.